Okay, so we're going to take a look at something called solution stoichiometry, and this is something that we can apply with acid-base reactions to help us determine the concentration of an acid or base that's unknown. And so we did an activity in class, or it was on a previous video, where we started out with some acid in a beaker, right? So we had some HCl in a beaker, and then we added base to the beaker, and we said, okay, how much base does it take to neutralize our acid? And we can use this information to figure out how much acid was in this original beaker. So we're going to walk through how we would go about doing this. And then we're going to do another version of this next week. And this is something that we call a titration. And a titration is when you add a substance of a known concentration to a substance of an unknown concentration and trying to figure out how much stuff you have here. Okay, so the reaction that we took a look at, our acid was HCl, and the base we were adding was sodium hydroxide. So first we're going to ask ourselves, well, what is this reaction that's occurring? So our reaction is between HCl and sodium hydroxide. This is a double displacement reaction. We form sodium chloride and water. So this is what we have is our acid and a base is going to make a salt plus water. So it's turning into salt water. So it's neutralizing. And what we observed here is we are taking some data here where, let's say we observed it took 130 milliliters of a 0.2 molar solution of NaOH to neutralize a 60 ml solution of HCl. So first thing we want to do is figure out how many moles of NaOH we added. So for one of these substances, you're going to know the molarity and the volume, and you can use that to determine moles. So a reminder is molarity is moles per liter. So I can rearrange that and say moles is molarity times liters. So my molarity is 0.2. I need to convert that milliliters into liters. I do that by, dividing by 1,000. And then I do 0.2 times 0.13, and that gives me 0.026 moles of sodium hydroxide. Okay, so then that's how much sodium hydroxide I added. I want to figure out how much HCl was in my beaker. That's my unknown. That's what I'm trying to figure out. So my base is my known. I know the concentration. My HCl is my unknown. That's the thing I'm trying to figure out. So what I do know is the ratio in which they react. So if you look at this chemical equation, it's balanced. You see they react in a 1-to-1 mole ratio. So for every 1 sodium hydroxide, we had 1 HCl. That's what this kind of recipe is telling us. So if we had 0.026 moles of sodium hydroxide, then that means we had 0.026 moles of HCl. It's a 1-to-1 mole ratio. This won't always be a 1-to-1 ratio. So it's a 1-to-2 ratio or a 1-to-3 ratio. So this is a very important step. We've got to make sure we don't skip there. All right, and then let's figure out what is the molarity of the HCl. Well, molarity is moles per liter. So the moles of the HCl, we just said is 0.026 moles. And then the volume of the HCl, let's go back up here, it's 60 milliliters. And remember, we got to convert that volume from liters into milliliters. That's an important step to remember there. So that's 0.06 liters there. So we have 0.026 divided by 0.06. And it looks like our molarity is 0.43 molar. So this is an example of a stoichiometry problem. We call it stoichiometry because it's calculation involving a chemical reaction that relies upon this mole ratio here. And it's solution stoichiometry because we're using our knowledge of solution concentration and molarity to do this calculation.